Okay, thanks for joining me for the second video on trig equations from the trig topic higher maths. Again, we're just going to look at a couple of examples today, including compound angles and double angles basically. We've learnt a couple more things since the last video on trig equations and now we're going to use them. Okay, now firstly we've got something that looks slightly more complicated here. 2 lots of cos x cos 30 minus sin x sin 30 is equal to root 3. Now, what we should be noticing here is actually this bracket here is a version of our addition formula. So that thing there, that is really cos of x plus 30. So our equation becomes 2 lots of cos x plus 30 is equal to root 3. And then it's just exactly the same as it was before. Divide by 2. Do your cos. Okay, deal with the cast diagram in the first and the fourth. Inverse cos of root 3 over 2 is 30 degrees because we're dealing in degrees. So our bracket x plus 30 in the first quadrant is equal to 30 degrees, and in the fourth quadrant is equal to 330 degrees. Which means if we're adding 30 here, we need to subtract 30. So that's going to be 0. It's going to be 300. And just a slight trick here, most questions will be finished there, but because it's at 0, we know it has to be repeated again 360 degrees later because it's a single x. So you're also going to have the 360 degrees included at the end there. That's going to come within our range because there's an equals here as well. That's just a wee quirk for this question. But the key thing here, the new thing, is replacing that with your addition formula. Okay, now the next 2 equations we're going to look at are both kind of similar in that they include this sine 2x or cos 2x. Now, something I like to have my kids remember is that if you have 2 different types of equations, you're going to be using the double angle formula. Okay, now sine 2x, that's the same as 2 sine x cos x. Now we may look as if we're making it more complicated here, but actually now we have a common factor between those 2 terms. Okay, so you have 2 different terms, you'll be using the double angle formula, and then you will be factorising. So we've got a cos x in common between those 2. So take cos x to the front of your bracket, you're left with 2 sine x minus 1 is equal to 0. And then you can solve the 2 strands, cos x is equal to 0, or 2 sin x minus 1 is equal to 0. Now cos x is equal to 0, that's one where we look at a graph. Okay, it's going to be here and here. We're looking at radians, so it's going to be pi over 2 or 3 pi over 2. Okay, and from here, add 1 divided by 2 is going to be 1 over 2, and then get rid of your sign, you're dealing in quadrants 1 and 2. Inverse sine of a half is 30 or pi over 6 in radians. So my 2 solutions from here are pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. So there's my 4 solutions. Okay, now 2 things to deal with, 2 different trig terms, double angle formula to substitute in, and then factorise. Okay, and a similar example here, we've got 2 different terms to deal with. We've got a cos 2x and we've got a cos x, so we need to use a double angle formula. Now the problem here is we have 3 options for cos 2x. We have the one with sine and cos, the one with cos, and the one with sine. Now because the other thing involved here is a cos, we are going to use the expansion that just uses cos. So this is going to be replaced by 2 cos squared x minus 1 plus cos x plus 1 is equal to 0. Okay, then that minus 1 plus 1 cancels, so 2 cos squared x. Oops, apologies, plus cos x is equal to 0. And again, we're going to factorise. Cos x comes out as a common factor. So 2 cos x plus 1. And very similar to the last one, we now just solve each strand. So cos x equals 0, which means x, we know already, is 19,270 from the graph from last time. And 2 cos x plus 1 equals 0. Equals negative 1 divided by 2, so negative a half. We're dealing with our cast diagram now in quadrants 2 and 3. Inverse cos of a half is 60. So in quadrant 2, that is going to be 120, and in quadrant 3, that is going to be 240. So my solutions are here and here. Yeah, those are two quite similar examples at the end. It may be better to pick a different one, but it's going to always be the same. If you are dealing with two things that are different, two different trig terms, you're going to need double angle and you're going to need to factorise. The only difference there, the only thing that will make it more complicated is your factorisation will be more complicated. You might need to do a trinomial rather than a common factor, but the principle holds. Okay, give me a shout when you need a hand. Cheers. Cheers.